Let's take a look at this quadratic trinomial. If we use the b squared minus 4ac square root rule, we can find that yes, indeed, it is factorable. However, if we look at the factors of 2, we only have 1 and 2, and there's no way we can generate a 7 from this. So there's got to be a different way of handling this. And the first thing you'll understand is this is not a quadratic trinomial with a leading coefficient of 1, which we've seen so far. So anything with a leading coefficient that isn't 1, we have to treat differently. So we anticipate a solution of the form ax plus b times cx plus d will be the factored version of this. Now if we write ax times cx, we're going to get acx squared. If we write ax times d, we're going to get adx. If we do the inner term here, we're going to get bcx. And finally, the outer or last term here, we're going to get bd by itself. Now, if we combine terms, we're going to get this expression here. And we can see that ac here has to equal 3. We can also see over here that bd has to equal 2. Also, we find that ad plus bc has to equal 7. What we're going to do next is write down all combinations of AC that will give us 3, such as 1 and 3 and 3 and 1. We're also going to write down all combinations of B and D that are going to give us 2, which is 1 and 2, 2 and 1. So we want to go through all combinations of 1 and 3 with BD being 1 and 2 and 2 and 1. And we also want to go through all combinations of 3 and 1 where we have 1 and 2 and 2 and 1 here. Now if we start substituting in for A into this formula AD plus BC, we find that A here is a 1, we find that D here is a 2, and we're going to find that B is a 1, and C is a 3. And when we multiply 1 times 2 plus 1 times 3, we get 5, which is wrong, so we can stroke this combination right off our list. We can also take a look at the next combination where again A is 1, C is 3, and B is 2, and D is 1. And when we add this up, we're going to get 5 again, which means we can stroke this combination off our list. Let's take a look at the next one. We've got A is 3, we've got C is 1, we've got B is 1, and we've got D is 2. And this time we multiply 3 times 2 and get 6 plus 1 is 7, so this one works. Let's just continue on just to make sure we have no other combinations. So in this case we've got A is 3, we've got C is 1, we've got B is 2, and we've got D is 1, which is going to give us 5, so we can stroke that off. So this is the only combination that will work here. So we can find our solutions: A equals 3, B equals 1, C equals 1, and D equals 2. Let's validate it by putting it into our equation here. So this is 3x times x, which is 3x squared. The outer term is 3x times 2, which is plus 6x. Do the inner term, which is plus x. And then the last term, plus 2. And when we combine our terms, we get 3x squared plus 7x plus 2, which means this is indeed the factored solution of this expression here. Another technique when there's a non-leading coefficient of 1 for the quadratic trinomial is to multiply the first term here by the constant. In this case, we have 36. Now 36 has a lot of factors, and if we want to combine factors to get minus 16x, we can find that 18, 2 is going to give us that. So all we're going to do is, once we figure this out, is we're going to write 3x squared minus 18 plus 2x minus 12. And it hasn't really changed anything other than the 16x up into 2 terms. Now if we divide 3x into 3x squared minus 18, we get 3x times x minus 6. If we divide 2 into 2x minus 12, we get 2 times x minus 6, which we can combine to be a factor of x minus 6 times 3x plus 2. When we do the validation, we find that indeed we get back the original equation up here. So that means that this is the factor of this particular expression that we've got here. Before trying to factor an expression like this, a lot of times it's better to simplify it by using an intermediate variable such as a and setting it equal to x plus y to the 3n. I think you can see that when we do that, this expression here will then turn out to be 12a squared, this one will be minus az, and this one will be minus 6z squared here. Now we've got terms in a and z, so let's just temporarily get rid of anything in z. And we're left with this expression here. And again, we can use the factors of 6, are 1, 2, 3, and 6. And we need something to generate -1, and at the same time multiply to give us -6. And I think we'll find that 3 and 2 will do that quite nicely. So 2 subtract 3 is -1. 2 times -3 is -6. And that's why we have this expression here as our factor of 12a squared minus a minus 6. But to finish it off, we have to put back in our expression for z, and I think you'll find that that's going to be 4a minus 3z times 3a plus 2z to give us this. Going from here to our final version, we have to substitute back in for a here, x plus y to the 3n. And when we do, we're going to end up with this as our final result. Let's take a look at factoring by grouping. If we have an expression that has more than 3 terms, such as this, we can then start breaking it down into different things, such as ab plus 4a and 3b plus 12. And take out a common factor of a and we get b plus 4. Take out a common factor of 3, we get b plus 4. So then we can factor this as a plus 3 times b plus 4. Let's take a look at factoring x squared minus y squared plus 2x plus 1. And if we collect the x terms, x squared plus 2x here, and then put in minus y squared plus 1, you'll notice that if we want, we can take this and say x squared plus 2x plus 1 minus y squared. And what this will do is it will factor into x plus 1 times x plus 1 minus y squared, which is like x plus 1 squared minus y squared. And the difference of 2 squares is shown here. So this would then be the factor of the original one up here. A perfect square trinomial is really a binomial that is squared. For instance, if we take the binomial 2x plus 3 and square it, we're going to get this trinomial. Now one of the things you're going to notice is that in a perfect square trinomial, the 4 here will be the square of this, the 9 here will be the square of this, and this term times 2 will give you the middle term. If you have a plus b squared, you're going to get a squared plus 2ab plus b squared, where this again is 2 times the outer terms here. And if you have a minus b squared, that's a squared minus 2ab plus b squared, where again these are squared of the first terms, and the middle term is really these 2 times 2 to give you this. To be able to factor a perfect square trinomial, you have to realize that you have a perfect square trinomial. Let's take a look at this example here. If we take the square root of this term, it's 1. If we take the square root of this term, it's 2. 2 times 1 times 2 will give us the middle term, and this is what's going to give you reality that this is indeed a perfect square trinomial that you are going to factor. Even though you may recognize it as a perfect square trinomial and you come up with a solution, you should actually multiply it all back and validate that this indeed works. Let's take a look at this trinomial here, and you can factor it down to here. Now when you do that, you can say let w equal 3xy, which will give you w squared minus 2w plus 1. And if we take a look at the square root of this term, it's 1. Square root of this term, it's 1. Multiply it by 2, and indeed we get this back here. So that's why we can then very easily write this back by substituting back in w, this particular factor for this original expression here.